In this demonstration, we are going to understand about Kubernetes services. Now, let me start with a brief description. Kubernetes pods are generally mortal. Now, what that means? Generally, they can burn or they can die at any point of time. Whenever a Kubernetes pod gets died, you cannot recirculate it or recreate it, or you cannot recover it. So generally what happens, to avoid that problem, we started using deployments to run our applications. Now, if you use deployments, in case if your pod gets killed off, it is the responsibility of the deployment to get it back. Now, what happens? Each pod gets its own IP address. However, in a deployment, there are a set of pods running at a moment of time. Now, whenever there is a pod got killed, then that pod gets a new IP address. That means at a point of time, okay, if you have 4 different IP addresses in deployments, then the next moment you may not have the same, because the pod got killed and you may get a new different set of IP addresses. This actually leads to a problem. If some set of pods, for example, call it as a backend pod, is providing you a functionality, and there are other set of pods, call it as front end, which are there inside your cluster. Now, how do you ensure that your front end will actually find the right backend? Now what if you have 4 backends and 4 front ends? Now which front end will talk to which backend? It's a problem. To solve this kind of problem, in Kubernetes we have a concept called service. Now, a service is actually an abstraction which actually defines a logical set of pods and also defines a policies by which we can access some of the only specified backend pods. Now, the way of doing this activity is called as microservices pattern, and that is what all about. So generally, the set of pods are targeted by a service which is usually determined by a selector, which we have seen in the last demo. I understand that it's a lot of theory. Now let's go ahead and see a bit of practicals and then understand more. Now let me go ahead and show you if I have any current deployments. Now if you see, I have 2 deployments. Let me go ahead and clear the older deployments. Now I don't have any deployments. I think it's very clear. Now let me also check if I have any services. So to see whether if I have any services or not, you can type kubectl get services, or you can also type kubectl get svc. Now by default you can see something called as Kubernetes. The type is cluster IP. Don't worry, we are going to understand them as we progress. Now let's go ahead and create one service. Let me explain you once I type it. Let me show you a demo of working and then I'll give you a description. Now what happens? The server is actually telling that it cannot find a bootcamp. So let's go ahead and run. Okay, it's actually having a difficulty in running. Let's go ahead and run once again. Let me go ahead and run a Kubernetes bootcamp application, and then let me go ahead and do it. So for example, let me quickly do a deployment change, and then it's easy. See, I can go ahead and change something like this, or I can actually go ahead and run a deployment itself. Let me see if I can run a deployment. kubectl. Okay, kubectl apply. I'm sorry, it's a typo error. So let's go ahead and see. Now, yes, I have a deployment. Now let me go ahead and show you if I have any service for this deployment. And you can see that for this deployment, I don't have any service. Now let's go ahead and create a service. Now, the one which I'm going to go ahead and create a service is this. For the given deployment, let me expose a service. So this is my deployment name. Now you see I have a port that got exposed. Let us see, do we have any changes here? No. Now let's see the services. Now if you can see, I have another service that got created. You can see that's a deployment, and I have something called NodePort. Okay, the one which I have mentioned here, and you can see the IP address here. I have an external IP nil. You can see port number 80 and the dynamic port that got assigned. Now this is how you will expose a service in Kubernetes. Okay, I will teach you NodePort as we progress, but at this moment understand that there is a service which actually points to a existing deployment. Now let me brief you more details on a service. A service in Kubernetes is actually like a REST object which is similar to a pod. Like all REST objects that we have, you can actually do a post service definition to the API server for creating a new instance too. Okay, now this service object, the one which you are seeing currently, okay, this one and this cluster IP, generally we do a DNS mapping. That means if I ping this or if I ping this, it's going to respond it to me. So one container can, the one pod can actually ping to another pod with this name. So that's your DNS label name. Generally Kubernetes assigns a service, that is your Spring deployment, an IP address. Okay, now by default this is called as cluster IP. So this is the one which gets created by default is a cluster IP until and unless you change it to NodePort. Okay, now how do I know which node it is running? In a minute we will understand. Okay, generally what happens is pod definitions in the pods have pod names. You can also reference a pod name with the target port. For example, my Nginx is running on 80. Now the target port is 8080. That's what I have mentioned on. But however, if you can see, it's only taking the 80 because this is where it is actually running on. Okay, but it did not pick up target port because I did not give it correctly. I wantedly has done that. So I just want to show you that a dynamic port gets created if you don't mention the target port correctly. Okay, let me go ahead and actually describe you one by one. So at this moment, just understand that there is something called service, and this service gets exposed on a port, and that port gets mapped to the backend container port that is running. Just keep this in mind. As we progress, I'll explain you 3 different services. Now, generally what happens is every service has a different type. Now, I'm going to show you 3 different types. One is a NodePort, cluster IP, and load balancer. First, let me start with a NodePort. Before that, let me go ahead and clear all the SVCs. Now, the Kubernetes is by default there, so you cannot do anything with that. So I just cleared an SVC. Now let me show you a service manifest file. Now this is a NodePort service manifest file. Okay, let me go ahead and run it, and then I'll show you how it works. Now kubectl apply -f. So I have just applied a service. Okay, now you can see it here, the same configuration file I have updated and run it. Nginx service NodePort, and you can see Nginx service NodePort. Okay, now you have the NodePort type and you have the cluster IP. Okay, you have the NodePort, so you can clearly see here I have a NodePort, and you can see the NodePort. Now what if I want to make it as a load balancer? I can go ahead and create a load balancer. Okay, now let me give you a quick brief. Generally, services are those which abstract actually the Kubernetes pods. Now they can also abstract the backend pods. For example, if you have an external database cluster in production, but in your test environment you use your own databases, you want to point your service to a service in a different namespace or another namespace, or you are trying to migrate a load to Kubernetes, which you are evaluating the approach of, okay, whether I need to forward it to the backend or whether I need to forward it to the front end. All this are done with the help of NodePort. So generally, NodePort exposes a service on the node's IP with a static port that you can observe here. So it is a static port that is configured with an IP address. Now a cluster IP, the one which you are seeing here, okay, under cluster IP section, generally the NodePort actually directs the traffic that is coming on. For example, anything that is coming on this port, the NodePort is actually going to direct it to the appropriate pod. Now whenever you want to access this service, you will be using the node IP address :port number. Now before that, let me go ahead and show you nodes. Now if you observe clearly, I have master server and I have slave nodes. Let me test whether my slave is reachable or not. And you can see that my slave is, I'm able to reach my slave 1. Let me see if I'm able to reach my slave 1, 2. Yes, I'm able to reach. Now when you mention the node port, this is the node port's IP address. I'm able to reach my slaves. Now let me show you another trick. Now you can see here, this service is actually mapped to a backend system which has a run equals to Spring People Nginx. Okay, this is all about the node port. Now let's understand more on cluster IP. So before that, let me go ahead and show you. You will see pretty much everything the same. The only thing that you need to worry about is the type cluster IP. Now let's go ahead and run the cluster IP. So kubectl. Okay, before that, let me show you. This is the manifest file. I'm applying the Kubernetes with a cluster IP. Now let me go ahead and show you the cluster IP details. Let me clearly show you. Yes. You can see that I just created Nginx service cluster IP. This is the cluster IP, and you have received another IP address here. As I said, cluster IP is going to be the default. Okay, if I don't even mention it here, I'm going to get a cluster IP only. Now, choosing this value will actually make any service inside the cluster to be reachable. That means inside the cluster, if two services want to talk with each other, then cluster IP is the best one. Now let me go ahead and show you the load balancer part. It's going to be the same service here. The only thing is the type is going to change it as a load balancer. Let me apply the load balancer configuration and show it to you. Now I have applied a load balancer, and you can see one difference here. The same Nginx service, that's a load balancer, cluster IP, and you can see something in pending state. Now let's discuss more about this state, which is important. Most of the time, whenever you configure a load balancer, okay, if you are configuring a load balancer type in your internal infrastructure, it may not be a great deal. Generally what happens there is you create your own load balancer and then assign manually load balancer configuration. Now, however, the same can be achieved using ingress controller. Now, why generally we use load balancer, a very specific type? Most of your cloud providers which support external load balancers that can be defined dynamically by the cloud provider itself. For example, I have AWS, I have Azure, I have Google Cloud. Now all these three providers are dynamic provisioners. That means on the fly I can go ahead and provision load balancers. Now most of the providers, they provide Kubernetes managed services. Now when they provide Kubernetes managed services, they actually help the users to generate the load balancer dynamically. Now this load balancer will actually expose the services that are there inside your Kubernetes cluster outside of your cloud with a public IP address. Now, the benefit here is if you have a NodePort or a cluster IP services to which you have an external load balancer route, all these things are automatically created. Now, the thing you can see it as a difference here. Let me show you in a watch mode. You can still see, that means you can wait for some time because provisioning a load balancer here takes time. And also the actual creation of this load balancer happens asynchronously, and the information about this provisioned load balancer is automatically published in the service, and that is what I am going to actually show you. As I said, provisioning a load balancer will take some time. So that is the reason I am running my Kubernetes in watch mode, or I'm seeing the Kubernetes SVC service in a watch mode, so that as soon as the provisioning if the cluster is done, I can go ahead and see it. So let's wait for the Kubernetes load balancer for this service to come up. as it takes some time, let's go ahead and show you something else. So let me get you the services. Okay, now let me describe a service and show you. For example, let me describe load balancer service itself, which we are working on. Okay, now you can see this is the service description. Okay, and you can see the endpoints that are going to be configured. External traffic policy is cluster, events, and the type is load balancer. Let me go ahead and show you another one. For example, cluster IP. Okay, no, which is going to give you the cluster IP details. Let me go ahead and show you the NodePort. This is the NodePort configuration. So it's taking a while. So let's run it and keep it. Now you can observe that this got created on an average of 5 minutes 33 seconds. So it's still taking some time for us to get the load balancer. As I said, it's a dynamic provisioner, so load balancer gets created automatically by the cloud provider, and that's there. And one thing is, just forgot to tell you, this load balancer dynamic provision will only work in cloud provider. If you are running a Kubernetes on your cloud providers, that too when you are a managed services, then only this gets provisioned. Okay, in case if you are not running a managed services of a Kubernetes cluster, this will be in pending state only. That is the reason in my case also it will be in pending state, because I'm not running a managed service cluster. I'm running a separate Kubernetes cluster which is running on VM instances. Okay, so that's pretty much for this demo.